Hi, this is Maggie from Design Code Debug Repeat. Welcome to the channel. If you're here because you want to learn to program in Java, you're in the right place. This is the 9th video in the Introductory Programming in Java full course and the 8th and final video of Lesson 2, Input Processing Output Programs. In the next lesson, we'll move on to branching programs. For this final video in Lesson 2, we're going to talk about two properties of programs that are critical to understanding how they work: flow of control and program state. We'll explore these properties using Eclipse's debugger. Let's get right into it. I have here the moonweight age calculator.java program from earlier videos. If we run the program, it prompts for a weight on Earth. I'll type 100. And it prompts for an age on Earth. I'll type 20. It then displays your weight on the moon is 16.53, etc. And your age on the moon is 270.4. You can think of any program as having a state. At this time, we will define the state of the program as the values in the variables at any point during program execution. And it's that at any point during program execution that references the flow of control. A program state is not static. It can change as the program executes. So it is very important to know in what order the lines of code in a program are executing, because the lines of code depend on and will change the program's state. The default flow of control in a program, the default order in which lines of code are executed, is sequential. Sequential means in sequence, top to bottom in the program. A debugger allows us to watch a program executing line by line, and as the program executes, it allows us to see its state. We can see the values in each variable as each line of code executes. To debug a program in Eclipse, we have to tell it where we want it to stop so we can examine the state and start executing line by line. We do this by setting a breakpoint. To add a breakpoint to this program, I'm going to right-click to the left of line 17 in that blue margin, and from the context-sensitive menu, choose Toggle Breakpoint. You'll notice that now there's a blue circle next to line 17. That's a breakpoint. A breakpoint has to be on an executable line of code. I can't toggle a breakpoint on a curly brace or a comment because those lines don't execute. If I want to remove the breakpoint, I right-click over the breakpoint and choose Toggle Breakpoint again. Let's put it back now. Once we've set the breakpoint, to execute the program in the debugger, either click the bug up in the toolbar or choose Debug as Java Application from the Run menu. Eclipse will execute the program normally up to the breakpoint, and then it will ask if you want to switch to the debug perspective. Remember that a perspective is the configuration of panes in the window. We want to switch, so I'll click the switch button. In the debug perspective, we can still see our code, and notice that the line on which we set the breakpoint is highlighted in green. That's telling us that the debugger has stopped there, and that will be the next line to execute. In the upper right, we have a pane with a tab labeled Variables. Right now, we have just args there. You may not have realized that the args in public static void main string args was a variable, but it is. What we're going to do is step through this program as it executes, line by line, and watch the values in the variables. Up in the toolbar, the debug controls are on the left, next to New and Save. The ones we'll want to use the most are the arrows. For now, we'll want to use Step Over. If you mouse over these buttons, you can see their names. The Step Over button will step over the current line of code executing it. Our current line of code is line 17, the assignment of 9.81 to the constant Earth gravity. Let's step over that and see what changes in our window. Notice that two things happened. In the Variables tab, we now see, under the Name column, Earth gravity, and in the same row but under the Value column, 9.81. That variable now has the value 9.81. And in our program, the arrow in the blue bar to the left of the code has moved down to line 18, and line 18 is now highlighted green. We'll press the Step Over button 2 more times, and note that after each constant or variable assignment, we see a new variable in the variables table with the value that was assigned to it. Now we're down to the line in which the scanner object is created. If we step over that, we can see our scanner over in the Variables tab, and there's an arrow next to it. A scanner is an object, which means it is a collection of variables. We'll learn a lot more about objects later in this course. If we click the arrow, we can see a scanner is a very complicated object. For now, we'll leave that scanner closed up. Now we'll execute lines 29 and 30, reading in the earth weight variable. I'll need to interact with the program in the console. I'll type 100. And we can see the 100 I typed converted to a double. You can tell by the 0.0 over in the variables area. We'll do the same for the age prompt. I'll type 20. And we'll step over the line of code closing the scanner. Notice, by the way, that execution has been sequential. We've executed each line of code in order, top to bottom, in our main method. Now we're on line 36, the calculation of moon weight. We can look in the variables area to see what the values of the variables in the expression are. Earth weight is 100.0, Earth gravity is 9.81, and moon gravity is 1.622. Those values are part of the state of the program. This calculation uses the current state of the program. If earlier or later in program execution, any of those variables had different values, it wouldn't matter. The values used in the calculation are the values that the variables have when this line is reached for execution. So we'll step over, and we can see the result of that calculation assigned to the variable moon weight, and now we can step over the moon age calculation, which will use the current values in the variables Earth age and moon rotations. And once we step over, we can see that variable in the Variables tab. And now we can step over the final 2 print lines. Now, if you accidentally step in, I'll press the Step Into button, which is to the left of the Step Over button. You'll see that a file opens up, which is part of the Java JRE system library that is part of our project. In this case, it opened the String Builder class. This can be a little confusing and intimidating when it happens. When we step into, we're stepping into a method call. In this case, first we're concatenating strings, and then once that argument is built, we would step into the printline method. When this happens, as you probably don't want to step through the Java system library, you can press the Step Return button to the right of the Step Over button. You might have to press it a few times to get back to your program, depending on how deeply you've accidentally stepped into the Java library code. And then you can continue stepping over the lines of code in your program. And we're done executing the program in the debugger. You might be wondering what the big deal is with the debugger. Why is it such a critical tool? When we write a program, we hopefully have a clear idea of how it's working, how our lines of code are taking the current state of the variables and transforming them into a new state. As you're just learning, you might not have that clear idea. You might be putting together things you've seen in other programs and making some educated guesses. In that case, I strongly recommend you run your programs in the debugger to see exactly what each line of code is doing. Making an educated guess is fine to start, but you can't put code that you don't understand into production. Once you've made that guess, walk through your program in the debugger and learn how it works. Now, what about experienced programmers? Experienced programmers do have a clear idea of how their programs are working. So when there's a bug, when their program doesn't produce the correct output, their clear idea is wrong. It happens to me all the time. The debugger allows experienced programmers to see exactly how their idea is wrong by showing them which lines of code are executing and what the state of the program is as each line executes. This tool will become more important as our programs become more complex, and as we add Java constructs that change the flow of control, that branch or loop or jump into methods. We will revisit the debugger in each lesson to illustrate what useful information it offers about the constructs we're learning, and how to use it effectively to debug programs that have become complex in new ways. Let's debug a broken program. I have here a program called moonWeight error. It's a broken version of the program that obtains the user's weight and calculates their weight on the moon. We know from our last program that if the user weighs 100 pounds on Earth, they will weigh approximately 16.5 pounds on the moon. Let's run our broken program and enter 100 at the prompt. Okay, it says please enter your weight on Earth, and I type 100, enter, and it tells me your weight on the moon is 0. So something isn't quite right. Let's put a breakpoint on line 16, in which the Earth gravity constant is assigned the value 9.81. And click the bug icon to run the program in the debugger. Now, when a program doesn't work, it's important that you debug it slowly and thoughtfully, first predicting which line of code will execute next, and what the type of each variable and value in each variable should be after the line executes, and then confirming by stepping over the line. I predict that after line 16 executes, the Earth gravity variable, a double, will have the value 9.81. I'll step over, and that is what I see. I predict that after line 17 executes, the double variable moon gravity will have the value 1.622. I'll step over, and that's what I see. Now, line 19 is just a variable declaration, not an executable line of code, so Eclipse doesn't stop on that line. After line 20 executes, I can see Earth weight is being declared and it's being assigned a default value of 0. If I'm the programmer, I hopefully know why I gave it that default value. If I'm not the programmer, I might be a little puzzled why it's being given a default value if we're going to be obtaining that value from the user. But I will step over it and expect that it will be a double with the value 0.0, and that's what I see. Now, the same for moon weight on line 21. I don't know why that's being given an initial value, but after this line executes, I expect it will have the double value 0.0. And it does. Now, on the next few lines, we're creating the scanner and obtaining the Earth weight from the user. So I expect after these lines of code execute, I'll see that scanner object over in the variables area, and if I type 100 at the prompt, I'll expect Earth weight to have the value 100.0. Let's step over lines 24 and 25. So after line 24, I see the scanner over in the variables area. And after line 25, I see the prompt, and now we're on line 26, standardin.nextDouble. I'll step over that and type 100, and if I'm the programmer, I might expect that Earth weight is going to change to 100.0. But notice that the value in Earth weight did not change. So we have found the line of code that's causing the bug. If Earth weight is still 0.0, then when the calculation is executed on line 30, the value 0.0 is going to be used in the calculation, giving us 0.0. Let's step over and watch that happen. Now I think I see why the programmer put those default or initial values of 0 in for the variable Earth weight. Let's see what happens if I take those assignments of 0 out on lines 20 and 21. Now I can see there's a syntax error on line 30, and if I mouse over it, it says the local variable Earth weight may not have been initialized. This, by the way, is the sort of error I see beginning programmers make. That is why I chose this error for this program. When you have any kind of error, it's very important that you understand what's causing the error before you try to fix it. The programmer here tried to fix the problem by giving Earth weight an initial value of 0. And they threw in an initial value for moon weight too, just for good measure. Perhaps they interpreted the word initialize in the error to mean they had to give it a value where it's declared. Putting those zeros in, or really just the 0 for earth weight, makes the syntax error go away and allows the program to run. But the program runs with a semantic error. The programmer has introduced a bug that could be a lot harder to find than the initial syntax error. Do you see how to fix this program so it has no syntax or semantic errors? On line 26, when we're obtaining a double value from the user for their weight on Earth, we're not storing it in the variable earth weight. This is the line on which the variable should be initialized or given a value. If we write earth weight equals standardin.nextDouble, now we lose the error and the program will run correctly. Let's run it and type 100 at the prompt. And we're told we will weigh approximately 16.5 pounds on the moon. Now, when you are finished debugging, to switch back to the Java perspective, you can click the little icon in the upper right corner of the window next to the debug perspective icon, or you can go to the window menu and choose Perspective, Open Perspective, Java. You can see that you can open the debug perspective there as well if you like, or click the debug perspective icon in the upper right corner of the window when you want to start debugging. There is an auto-graded exercise in the description of this video to help you practice with this. Click on the link and you'll go to an exercise that allows you to step through the moon weight error program and enter the values in the variables as the program executes. This is a good way to test whether you understand how each line of code is impacting the program's state. I also urge you to run programs that we've written in other videos in the debugger. Predict the changes to the program state at each line of code and confirm that your predictions are correct with the Eclipse debugger. When you're feeling confident with the concepts in the 8 videos in this lesson, you're ready to move on. As always, have fun and keep coding.